This is the lesson 1.5 boxes and bullets. This is on means and extremes, which is a way of solving proportions when scaling up and scaling down just aren't working very well for us. So when we have a proportion, the means, and I'm going to use my marking the text now. So we double underline our vocab words. We're going to underline the definitions, and we're circling some of our data. So the means are the two values in the middle. So when we set it up this way, it's hard to tell what's in the middle. But if I write this ratio this way, and I write 8/10 as 8 to 10 this way, the two in the middle right here, those are my means. And then these two are the extremes, which makes sense because they're on the extreme outer sides. So these are the extremes, and these two are the means. So in a proportional relationship, the means is always equal to the extremes. So we can easily prove that 5 times 8 is 40, 4 times 10 is 40. That will always be the case if we have a proportional relationship. Remember that it's really important to use labels. We're going to use variables, which again, those are the letters or symbols used to represent a number. Inverse operations is a new term. Those are operations that undo each other. So think of undoing addition would be subtraction. Undoing multiplication is division. Those would be inverse operations. So let's look at an example and see if we can set this up as a proportion and use means and extremes. If we have 140 red phone covers were sold out of 500 total phone covers sold. So I'm going to write that as a fraction. 140 red out of 500 total. If I'm going to make this a proportion, I'm going to right away bring over my labels. It says, how many red phone covers were sold if 700 total were sold? So 700 total goes here. There's my variable. 500 times nothing easy gets me to 700. So I'm going to use means and extremes instead. I'm going to look at it and say the means, so 500 times x, 500x, equals the extremes, 140 times 700. Now we have to know how to solve this. So I have to do as much work as I can. I like to draw railroad tracks on either side of my equals. So over here I can do some work. I can take 140 times 700, and that gives me 98,000. And that equals 500x. So this means 500 times x. When I'm solving an equation, I use inverse operations. The opposite of multiplication is division. So the way I show division is with a fraction bar. This means divide. Divide by 500. But what I do to one side, I have to do to the other. Divide by 500. 500 divided by 500 is just 1x. I don't need to put a 1 there. Now if I take 98,000 and divide it by 500, I get 196, which means there would be 196 red phone covers sold. If we had 700 total. Okay, so that's off of a word problem, but we can also have a table. So the table shows the relationship between the number of chocolate chips that are in cookies. Use means and extremes to calculate missing values. I'm going to just start right here, and I'm just going to set it up as if it's a fraction. I'm going to say x chocolate chips in 35 cookies, and then I'm going to bring over my labels right away. There's 108 and 18. Okay, so now really I'm working this direction to the left because here's the ratio where I know both pieces. I don't know 18 times what gives me 35. I'm going to use means and extremes. So again, 35 times 108 equals x times 18, which is 18x. So 35 times 108 gives me 3,780 equals 18x. And now I'm going to undo because I want to get x all by itself. So I need to get rid of this 18. It's multiplication. I undo it by division. If I divide the right side of the equals by 18, I better do the same to the other. So 18 divided by 18 is 1x. Notice how I always work down. And when I take 3,780 divided by 18, I get 210. So there would be 210 chocolate chips in 35 cookies. Now I'm going to do this again to figure out this. So maybe here I'll use these two. I'll say 108 chocolate chips in 18 cookies equals 144 chocolate chips. This time the letters Y in Y cookies. Again, I don't know 108 times what gives me 144. So I'm going to use means and extremes. 18 times 144 equals 108 times Y. 18 times 144 is 2,592 equals 108y. I need y all by itself. I don't want 108 y's, I want 1. So if I divide this side by 108, do the same thing over here. 108 divided by 108 is just 1y. When we divide the other side by 108, I get 24. So there would be 24 cookies. Okay, here, this one, I'm going to set up again 144 chocolate chips in 24 cookies. And now we have Z chocolate chips in 1 cookie. Here I actually could do scaling down because I see that 24 divided by 24 is 1. And 144 divided by 24 gives me 6. So I could use means and extremes again, or in this case, this makes more sense to just scale this one down. So now they asked what was the unit rate for chocolate chips in a cookie. A cookie means in 1 cookie. From the table I can see in 1 cookie there were 6 chocolate chips. Here's my unit rate. 6 chocolate chips to 1 cookie. So let's look at reflecting on this for a little bit. Why would I bother using means and extremes over scaling? Excuse me, scaling up or scaling down? When I look at these, here I did scale down. First thing, always scale up or scale down if you can. That is the easiest thing to do. But if we don't get an even number or a nice decimal to use, then means and extremes is going to be our way to go. So it's when we don't get a nice scale factor, then we want to use means and extremes.